Okay, good morning everyone. Kumusta? And I hope everyone is okay. So I will be sharing on how to solve problems in application of a definite integral wherein we have a plane area and rectangular coordinates. Now how to solve the area of a region bounded by a curve. Now, first, we have to make a sketch of the area to be solved. So draw or construct a rectangular element of the area which can be vertical or horizontal. Express its area as a function of x and dx when it is a vertical element or y and dy when it is a horizontal element. Now determine the limits of integration from the figure and integrate to obtain the area. Rough checking of the answer can be done by estimating it from the graph. Now, if you have a simple region, so this is a simple region if you have a boundary which could either be the x or y axis. So, in our figure, it shows a region which is bounded by the x-axis over an interval a to b, and that is bounded with a curve y equal to f of x. So, if you have to construct your your element of the area or your dA, so the element of the area will be constructed vertically because one of the boundary is the x-axis. So kung ang x-axis mo itong boundary, ang atong strip gamiton is a vertical strip. So the length of this is a variable height and this strip can be placed anywhere within the region. So if that's a variable height, because there's a moving point here, where the coordinates of that moving point are xy. So ang x nimo is based from the y-axis horizontally to the moving point. And your y is the vertical distance from the x-axis to the point. So, ang ato karong height ini is the variable height which is y. So, y times the dx is actually your dA. So, if you want to have the total area, then you can take a summation of this differential area. So, area is obtained by taking the integral of y dx over a limit of integration from a to b. So as a formula, in finding the area for a region under a curve, so the area is obtained as the integral of y dx, so with limits of integration from a to b. Now in order to make it integrable, your y will be expressed in terms of x, and that would depend on the equation of your curve involved. No? So we have this as our formula. Now if we have a problem here, wherein the area is required. So you have a curve used as a boundary, y equal to 2 square root of x and y equal to 0. So you have this, and y equal to 0 is a line which is the x-axis. So interval is given from x equal to 1 to x equal to 9. So we have to start with the figure. Okay, now if you are familiar with the curve involved, then you can easily arrive with the graph. Pero if in case nakalimot ka, unsay ato ang graph mapurma out from the given function, but still you can arrive with the graph by just considering the point plotting method. So if you have an interval from x to 9, then you can consider other value like 2 assigned to the function and you solve for y. Then you can locate your curve over this interval. Now, it's extended there, but actually we are not so particular with that because the curve wherein, or the region wherein we are interested to have the area is a region that is in between 1 to 9. Okay? Since our x-axis, or the line y equal to 0 is a boundary to the region, then I have to construct a vertical element. So, with the height of y and the thickness of dx. So, our dA, or the differential area, is y dx. Total area, or the area required A, is the integral of the y dx over a limit of integration where the region is formed with values of x equal to 1 to 9. So, muna yung ibutang diyan. Now, in order to make this integrable, then our y will be expressed in terms of x from the given function. So, you can now substitute and then you can integrate. So, from calculator, we have a value. So, because it can calculate a definite integral, so we obtain the area of 104 over 3 square units. If we have to solve it by formula, So, you can have our y substituted, which is equal to 2x to power 1 half for the square root of x dx. Then, we can apply a power rule of integration increasing by 1. 1 half becomes 3 halves over 3 halves with limits of integration 1 to 9. So, this can be 4 over 3. So, 4 over 3 is multiplied with the function value at upper limit. So, it's 9 raised to power 3 halves minus 1 raised to power 3 halves. And again, you can arrive with a value of the area which is equal to 104 over 3. Now, I have to recall a little in our analytic geometry, no? The kind of curve that's given. If you have y equal to 2 square root of x, actually, if you have to take the square both sides of your equation, then you arrive with y squared equal to 4x. So, if this is your equation of curve, so you will recall that your parabola is a parabola whose vertex can be found at the origin. And if the vertex at the origin, the parabola can open to the right. Or it can be at the left when this is minus the constant before your x. Okay? So, just to recall the equation of your parabola. Okay, so parabola with vertex at 0, 0 with the equation of y squared equal to plus minus 4ax. So, this is a parabola that can open to the right if this is a positive constant before your x. Or if that's negative, then it will open to the left. When the variable x is the one which is in second degree, because in a parabola, only one of the variable will be in second degree. So, if x is in square and y is in first degree, then that's a parabola that can open upward or downward. Plus, upward. When it's minus, then it will open downward. This is the equation of your parabola in standard form if ang imong vertex na sa origin. However, kung ang atong parabola has a vertex which is at any location hk, then you can have y minus k squared then equal to plus minus 4a x minus h as your equation. That is if your parabola will open to the right or to the left. But if it is x which comes first, then we can have x minus h squared then equal to plus minus 4a multiplied with y minus k when the parabola will open upward or downward. Okay? So, to determine the vertex and the position of your parabola, then you need to write your parabola. If it's given in a general form, then you can always reduce your equation into a standard form to determine the vertex and the possible position of our graph. The second curve we have is a cubical curve. We have y equal to x minus 1 or the cube of x minus 1 and the x-axis from x equal to 0 to x equal to 3. Again, if we are not so familiar with the curve, then we can always graph by considering the interval we have. Okay? So, we have 0 for x or x equal to 0. So, that refers to your or that is your vertical line which is the y-axis. So, 0 up to 3. So, if this is 1, then that's 2. Then we can plot our curve based on those values of x. When the value of x is 0, then your y will come out to be a negative 1. Correct? When it is 1, you substitute here, then it becomes 0. So, your curve will cross the x-axis. So, x equal to 1 is your x-intercept. But if your x becomes 2, your y becomes 1. So, if that becomes 1, so your curve will rise up. Okay? Then, when x is equal to 3, then you have y equal to 8. So, this is the point at which your curve will pass through. Okay? So, it goes down below the x-axis when the value of x is less than 1. Okay, so this is your y-intercept. Now, you cannot immediately take the value of the area by using 0 and 3 as the limits of integration, so which is now a different case with the previous. Because your curve, if you notice, no? So, do na say x-intercept. So, there is a region which can be found below the x-axis and there's also a region which is above the x-axis. So, you have to subdivide this into two parts. So, you have, maybe I can call this as a sub 1 and this as my a sub 2 and the area required is actually the sum of E1 and E2. So, I put an absolute value for E1 and E2 because if you calculate directly, there is a possibility of arriving with an area which is negative and a positive area. So, like for example, your E1, So, we can expect that the result here will come out to be negative. Because if we take a y dx for the dA and take the integral of that, we will notice nga ang atong y here is negative when that's below x. That is why, doing the integration directly, so the answer will come out to be a negative result. Okay, let's try with A1. A1 is equal to y dx. If that's y dx and y is replaced with a function x minus 1 to make it integrable with limits of integration, so imong tan-awon from the figure. If the region is formed from 0 with the x-intercept which is x equal to 1, so muna imong gamiton as limits of integration. So, doing the integration, you will arrive with the area which is a negative 1/4. Why negative is the result? Because the area is found below the x-axis. So, some may place a negative before, it is subjected to integration because if that's negative, then ibutang nimo siyang imong area as a positive area. The negative here only indicates the position of your region with respect to the x-axis. Now, expect that your ito is a positive result. So, nganong positive? Because ang imong area is found above the x-axis. Okay, with the same formula for area under a simple region, so we can have a length of our strip, a variable height. So, this height will vary kung imong ibutang anywhere within the region. It touches on your cubical curve. So, take note of the graph of a cubical curve. It is actually magingon ini. Okay? So, y and a dx. So, we integrate. We can have the ito and the region is formed from 1 up to where? Up to 3. You can use that as limit of integration. So, we really need a graph, no? Because we need to have our graph also be used to determine the limits of integration. So, if evaluated, we come up with a value of 4 square unit as the area. How about the total area needed or the area that is required? So, it is the sum of the absolute value of A1 plus the absolute value of ito. So, we have a negative 1/4 plus 4. Their absolute values are actually 1/4 plus 4 added. So, your area will come out as 17/4. And that can also be expressed in terms of decimal 4.25 square units. No? So, this example will also show us no, nga dili pwede atong integrate diretso the given interval as our limits of integration. Like, for example, using the limit 0 to 3 will arrive with an answer which is wrong. Because instead of having 4 be added to 1/4, it could be 4 which is subtracted to 1/4. In that case, you will arrive with an answer which is wrong. Okay, so here we have the number 3. If we know what the curve is, so we can easily take a graph. This is a line. Why? Because the variable x and y are both raised to power 1. We have another lines, two horizontal lines, y equal to 2 and y equal to 6, and x equal to 0 is the y-axis used as a boundary. So, if you take the graph, so mao ni ato akarong napurma. So, usually you have to start with curves which are easy to trace, like the horizontal lines, then the y-axis. Okay, so muna mo unahon. No, if you have to graph that manually, y equal to 2, y equal to 6, the y-axis, that's a boundary, then I'll be looking for this. If this is a line, and I want to plot it, so I may look for the intersection of this line with respect to these two horizontal lines. Now, if my y is 2, then I can solve for x, which is equal to 4. So, I can locate a point here. So, your line will pass through at this point. I can look for another point C when my y is equal to 6. So, 6 minus 10 is a negative 4 and then you transpose. So, we have 2 as the value of our x. So, these are the point at which your line will pass through. And this is the region that is covered because the boundaries are these curves. Okay? So, muna ito ang region that's covered. Since it is the y-axis which is used as a boundary to the region, so ang atong strip gamiton kay y-axis man so ang atong strip gamiton is a horizontal strip. And the length of your horizontal strip is a variable length. Okay? So the length of which is x. Because if you imagine that there's a moving point here with the coordinates of x and y, so ang imong x, ibase na to, will be based from the y-axis horizontally. So the length of your strip will serve as x. Katong imong y, so gikan dire padong sa padung sa x-axis. Okay, so x can be used as the length of your strip. What's the area of your element or the element of the area? So it is the length times width. So it is x and dy. To get the total area, then we can have the integral of x dy in order that our a can be obtained. So you integrate both sides and you have to contain this summation within the limit of integration for values of y because the variable of integration is y. So at what value of y the region is formed? It starts with 2 up to 6. So use that as a limit of integration. Unya, ang atong variable here is y. Then I can convert my x in terms of y. And my x is dependent with the equation of your line. So what is x equal to? That is 10 minus y, correct? And divided by 2 is your x. So, you substitute to your a. So, when it is substituted to your area with x equal to 10 minus y over 2, so integration is done and you obtain an answer which is 12 square unit as the area. But we can avoid integration. By the way, in constructing also a horizontal strip, if the region is at the right of the y-axis, ang imong area na mugawas nga positive result. Pero kung ang imong area to as sa left, then the area will come out as negative. Now, if you want that the area will be positive, no, upon evaluating, so let a negative sign be placed before you do the integration if the region is at the left of the y-axis. Now, how to avoid doing the integration on this kind of region? Now, take note that what we have is a trapezoid. And we know the area of a trapezoid. So, the area of the trapezoid is equal to 1/2 of the sum of the two parallel sides A and B multiplied with the altitude h. So, if we look at on the figure, if this is 4, which is the abscissa, so meaning this is in a length of 4. This is also in a length of 2. So, we can have 4 plus 2 divided by 2 or 1/2 of that, then you multiply with the distance between the two parallel sides. If that is 6, so this is 2, so this can be 4. So again, you will arrive with an answer which is 12. So we can avoid integration if we are working with common geometric figure, no? Now, if you also forget the area of a trapezoid, so pwede sa magkuha og area of a rectangle, and you know the area of a rectangle, so dugangan lang nimo og area of a triangle, no? So there you can also arrive with the same result. This trapezoid we have is actually kini. Two parallel sides of 4 and 2 with a distance of 4 here. So muna itong i-substitute to our formula. So use only integration if there is no formula that is available for us to use, or if ever we were able to forget the different formula of the common geometric figure. Okay, let's try working with the next. Unlike with the first three, this problem does not contain any, wala siya ay interval gihatag. Ang gihatag nimo is only the curve, and the other curve is the x-axis. When this is at the x-axis, so the x-axis again has the equation y equal to 0. So you just find the x-intercept of your, actually, this is still a parabola because this is in second degree imong x, ang imong y is in first degree. When x is in second degree, the parabola may open upward or downward, so it will pass through your x-axis in order to have an enclosed region. Okay? So I have to start working with the x-intercept by letting my y be 0. Y equal to 0 is the x-axis, so I'll be solving for the x-intercept. When my y is 0, then 6x minus x squared is equated to 0. I can express in factored form, removing x, so I have x with 6 minus x. So I have two values, so 0 and 6. So this will now form an interval on the x-axis where I can possibly draw my curve. So how to draw my curve and to show my bounded region? So I can consider 0 to 6. So 0, 1, 2, 3, 4. So I can look for the different points at which my curve will pass through. So like this one. So these are already pair of or coordinates of a point. So pwede na ka makagraph ini. Another way to trace this is to look for the vertex and After you know the vertex of your parabola and its possible position, so let your parabola to pass through this x-intercept and you can also have the graph. So these are possible options on how to trace your curve. So the parabola, so put your variable in secant degree at the left. So x squared when it is transposed, so minus 6x, and my y will also become negative y. I am inserting a term which is half of the constant coefficient here because kine, this is already 1. No? So this is completing the square method. So we have a minus 3 then square. So there I can have the binomial square. To neutralize the effect of a term added into an equation, so we can also add the same term on the other side. Factoring out a negative 1 before our y, so we have a negative 1, so we have a factor of y minus, this becomes minus 9. The vertex is a 3, 9. And since this is minus, then the parabola will open downward. And this is now the graph. Okay, so we have vertex 3, 9. The x-intercept is at 0, 0, and 6, 0. So you can approximate by having your parabola constructed that way. Now, if this is the vertex of the parabola, there is a line passing through here where our figure can be symmetrical. Okay? So, what is the area? The dA is y dx because this is a vertical element. Area here is expected to be positive because that is above the x-axis. So we have y dx, correct? So area is the integral of y dx with limits of, if you consider 0 to 6, then this is our area. But if you consider 0 to 3, so meaning half only is considered, then you can multiply by 2 to symmetry. And our limit pwede resag 0 to 3. So using this one, my y is now converted in terms of x to make it integrable because the variable of integration is x. So when the integration is done, then we arrive with the area which is equal to 36 square unit. By the way, another way of graphing this one, because you are actually facing your laptop or your computers, no? You can easily have the graph by using any graphing tool. In my case, I'm using the Mathway, no? So, muna akong gigamit to trace this. Okay, so, sayo na ang curve tracing. But in a face-to-face classes, no? So, dapat you must know this. Okay? So, that's all for this tutorial video. So, thank you for being around. And do not forget to share this to others. And please subscribe if you are new to our channel. Okay, so thank you.